Welcome back, everyone. In this lecture, we're going to discuss loading real image files. So what do I mean by a real image? Well, so far, we've only really dealt with nice pre-packaged, what are known as sometimes toy datasets, such as the MNIST dataset and Safari 10. These were already packaged for us in Torch Vision, which meant we could easily load them up and have them correctly formatted for us, as well as feeding in batches automatically. But what happens when we want to work with our own image files? Real image files such as .jpeg or .png. When we end up working with quote-unquote real image data, we need to keep in mind the various pre-processing steps that we can perform on the data. These are steps that deal with things like aspect ratios, scaling, normalization of the image, and then transforming the image to a tensor. We should also keep in mind that the datasets we saw with MNIST and Safari contain tens of thousands of images, and often our real image datasets won't be nearly as large. However, we already know that we need tens of thousands of images to get robust networks. So what approaches can we take to try to expand our datasets that don't involve us having to go collect more new images? What we can do is we can perform a variety of transformations to expand our data in a clever way. So let's imagine we have this original image of a dog, and maybe we have 1,000 of these images, but we want to increase the actual number of data points we have, so the number of images. Instead of having to go out and take another 1,000 photos of dogs, what we can do is a bunch of transformations on this. So something we can do is resize and crop the image. We can also flip the image on a horizontal axis or a vertical axis if that makes sense for the object you're trying to scan. And you can also rotate the image. So simple transformations like these allow us to greatly increase the number of data points. Even just performing an additional horizontal flip on all your data points will immediately double the amount of images you have, as well as make the model more robust to variations on an image. Since dogs could be facing either to the left or to the right, it's probably a good idea that you do that horizontal flip on this particular data set. And things like rotations also help out make the model more robust, as well as, again, increase the number of data points. Let's go ahead and explore how to load in this image data and perform these transformations. After this, in another series of lectures, we'll explore how to train on this quote-unquote real image data once it's been loaded, pre-processed, and had transformations on it. Let's get started by heading over to a Jupyter Notebook. All right, here we are in the Jupyter Notebook. Now, before we get started, we have to actually download the dataset. The dataset was too large to include in your original zip file of notebooks. So I've gone ahead and added a resource link to this lecture. And if you're unfamiliar with the resource link and how they work, you can just Google the Udemy support page for downloading supplemental resources. But if you've downloaded the notebooks, you pretty much should have already understood how to do that. Currently, Udemy system, the way it works right now, is that for downloading supplemental resources, you'll see a little resource folder, you click on that link, and you'll drop down and you should see a link to a Google Drive. Now, that Google Drive link is also present in the notebook that corresponds with this lecture. So if you're having issues with actually finding the link for the dataset, go ahead and either check the resources for this lecture that you're watching right now, or just open up the notebook for this lecture and it will also have the link. So please don't post to the Q&A forums until you've checked out either the supplemental resource link or you checked out the notebook. So once you've done that and clicked on that link, it should take you to a page that looks something like this. Might look a little different if you're actually signed into Google, but basically it has this cats_dogs.zip file, and it will say, whoops, there was a problem with the preview. That makes sense because this is too large of a file to preview, and it's essentially a zip file. There's nothing to preview. So what you need to do is just go ahead and click download. And it is a larger file, so if you have a slower internet connection, it will take time, but that's just the nature of this sort of problem that we're trying to work with here with convolutional neural networks. So I'm going to go ahead and download this. Okay, so I've already completed downloading this catsanddogs.zip file. So on my computer, underneath downloads folder or wherever you happen to save your internet downloads, in my case, I have it under downloads, other downloads, and then I have the cats_dog_zip. If you begin to open it, you may be able to explore the actual zip file. So basically, it's a giant folder called cats and dogs. There's a test set and a training set. And then each of these is essentially subdivided into cat and dog subfolders. And if you open one of these, then you essentially have a bunch of JPEG images. In this case, these are all images of dogs. So if I just go ahead and click on one of these, such as number 119, then here's this image of this dog. Okay, so what we want to do is put this in the correct location, and we also have to make sure to unzip the file. In fact, I haven't really unzipped it yet. So what I'm going to do is move this catsdogs.zip file. So notice it still has the zip. I'm going to move that zip to my data folder for this course. So let me go ahead and do that. Okay, so here under PyTorch Bootcamp, underneath data, we have the actual data files. What I'm going to do is I'm going to paste or just move the cats_dogs.zip file. And what I also have to do is I have to unzip this. There's a variety of ways you can unzip things. You can use either the macOS or Windows built-in default unzip file programs, or you can use something like WinRAR or 7-zip. It's really up to you. I assume that if you're learning about deep learning and Python, then you know how to unzip a file. So let's go ahead and unzip this. I'm just going to say extract all. So I'm just using the default with Windows. And again, macOS also has a default. If you're unfamiliar with these defaults, a quick Google search should answer that question. So I'll go ahead and click extract, and then I'll kind of use a default destination folder. And again, this may take a little bit of time because keep in mind, this is a really large number of images. So I'll go ahead and fast forward until this is done. For me, it's going to take a few minutes. All right, so this has finished unzipping, and now I have this folder, catsdogs, that I can check out. Let's come back to the Jupyter Notebook. And then what we're going to do is start off with a couple of standard imports. I'm just going to copy and paste what we've been using so far. We may not actually end up using all of these, but I'll go ahead and just import them anyways. And first we want to do is we want to examine the data. We're going to be using Python's built-in OS module in order to walk through the directories and collect file names. And then we'll also use the Pillow library, which is an extension of the Python Imaging Library, or PIL, to open the image files and extract things like image sizes. And then a pandas data frame will provide summary statistics on our data, things like max and min width and height, so we can help choose model parameters based off that. So let's go ahead and import just a couple more things here. We'll import OS, and we'll say from PIL, import image, and then from, and this is really only for displaying images inside the notebook. I'm going to say from ipython.display import display. Keep in mind you won't need to do this if you are not using a notebook. And then as you're working with Pillow, there are sometimes some known issues that just sprout warnings for you, and they're just warnings, they're not errors. So to not get kind of annoyed by these upcoming new version warnings, we'll go ahead and say import warnings, and then say warnings.filter warnings, and then just pass in the string ignore. So again, we're not ignoring errors, we're just ignoring some warnings that come up with just have to do with things like versioning issues. Next, let's go ahead and just display a picture of a single image so we can get an idea of the kind of files we're working with. So make sure before you even run anything, check the full file path of wherever you save these images. So make sure that you've kind of triple checked this full file path, otherwise you'll get an error. So I'm going to say with image.open, and there I'm going to write in the full file path. So I'll go back up a directory into my data folder, and you should be able to start tab auto-completing some of this. So I'll tab auto-complete cats and dogs, and then the specific way I saved it here for this filming is I accidentally doubled up and have another folder called cats dogs. Yours may be different, you may not have this double folder, so keep that in mind. And then I'm going to reach into the test folder. So there should be another test folder, then there should be another cat folder there, and I'll just choose a cat image. They're all just numbered. So I'll say 10107.jpg, and then we'll say as IM, and then we'll display IM. Go ahead and run this, and you should see an image of a cat. If you mess up this file path, so for instance, let's say I forgot to write cat here, and I just cut this off and run this, you'll get a file not found error. Please don't post to the Q&A forums if you have this file not found error. All it means is that you're simply either made a typo or you're not providing the correct file path. So please triple check the full file path. There's no way I can really know where the file path is on your computer from my end. So it's up to you to check to make sure you provided the correct file path. So again, if you get this file not found error, no such file or directory, please just triple, quadruple check what you need to do in order to provide the full file path. So I'll go ahead and run this, and there's the correct file path. Next, let's go ahead and create a list of the image file names. That way we can create a data frame, and then we will be able to do things like get summary statistics on the image sizes, such as width and height. And after that, what we will do is, in the next lecture, look at things like image preprocessing and image transformations. To create a list of image file names, I'm going to use the OS submodule of Python. So first, I need to set up my top level path. This top level path is the top level for cats dogs. Essentially, right before you get to test train, what is your file path? So I'm going to copy it here. In my case, I have the double cats dogs. Yours may be different. Again, I won't know what is on your computer. You'll have to kind of look that up yourself. And then I will create an empty list called image names. And what I will do is essentially using the OS walk function, I'm going to walk through the subdirectories of test, train, cat, and dog, and grab a list of all these image file names. So I will say for folder, comma, subfolders, comma, file names, and OS walk. And in that path, what I'm going to do is say for image in file names, grab image names, and append the file path, which is going to be folder plus a / plus that actual image. So go ahead and run that, and if you ran that correctly, you should be able to then check the names, and you should have 24,994 image names in there. So there's about 25,000 images. Keep in mind, these images are way more complex than what we were dealing with before. They have a variety of sizes and widths and heights, and also they may not all be centered. And recall that even for super nice data like the MNIST Digits dataset, we had something like 60,000 images. So here we have much less than that, and also the images are a lot more complex. So later on we'll have to provide transformations in order to try to generate more images from what we already have. But first, let's create a data frame to actually get an idea of the various sizes and shapes of these image files. We will say image sizes, and let's create an empty list here. And then we'll say rejected, which I will explain in a second. And then we'll say the following. We'll say for item in underscore image names. Go ahead and try to open it. We'll say with image open item as img. And then we'll grab that size. We'll say image sizes append that particular image dot size. And then just in case there's an error and you're not able to open it, we'll have an except clause. And if that's the case, maybe the image is too small or something, we'll simply just append the item. So hopefully we don't get any rejects, but just in case, depending on where you save this, if there's something that's not an image file, we'll go ahead and just add this little try except. All right, then what we're going to do is we're going to run this. Keep in mind, this may take a little bit of time because we're technically opening these guys, temporarily looking at them in memory, and then we'll grab their size. But the next thing we'll go ahead and do here is just check the length of the image sizes, and then check the length of if we rejected any files. So we'll go ahead and then run these two. Okay, so it looks like the length of rejected was 0, and I forgot to print out the length of image sizes so I could see both. Let's go ahead and just run print on both of them. Okay, so it looks like I didn't have any extra files there, so I didn't reject any. If you get a large number here on rejected, then I would say double check your file paths. Let's go ahead and convert this list to a data frame. We'll say df is equal to pd dot data frame, and then say image underscore sizes. Run that, and then if we check out the very head of this data frame, it looks something like this. So essentially this first 0, that's the width, and then 1 is the height. So let's go ahead and just get some summary stats on these. We'll say 0.describe, and these are the summary stats on the width. So it looks like the widths range from 42 to 500, where the median at 50% is 448. So that's good. We have majority of them, or at least the top half, are closer to the max. And we can also see the mean here is 404. So it looks like we don't have too many really small images, but there are a few, given that the minimum is 42. And then we'll say df1 and check the height of these images. And we should probably expect pretty similar behavior. There shouldn't be anything that's too abnormally maybe thin or wide. So we can see here again, max is 500. So the largest image is a 500 by 500 image, and looks like 50% or median is 375, and we can get the mean. Again, we have a few small images here, but based off the median and the means, we can basically ascertain that most of these image files are pretty good size. Okay, so this is going to be useful for deciding on an input size, and we're going to see later on when we actually build out the model, we technically have to decide what size we're going to say these images are. Because the way we're running convolutional neural networks and we're passing filters and we're doing a lot of operations on the incoming images in a convolutional neural network, we basically have to expand them or contract them all to the same size. So we want to choose something kind of in a sweet spot that tries to hit a good size for most of these images. That's why it's important to understand the width and height of these images for later on in the network training. So keep these numbers in mind. We'll be using them later on. All right, this is going to end part 1 of loading up the real image files. Coming up in part 2, we'll work on image pre-processing and the various transformations. I'll see you there.